First, thanks everybody for joining us here today. Just to make sure we're all in the right room, we'll be talking about how Fanduel migrated a mature data organization. So my name's Phillip. I'm a data engineer turned technical program manager, and I work out of the New York office.
My name's Mike Lee. I'm a senior data engineer on the data architecture team, and I'm also out of the New York office.
Hi, I'm Harry. I'm a senior data engineer for data delivery, and I'm based out of the Edinburgh office.
So here's a little glimpse of how we structured our presentation. Each of these sections ties to significant chapters in our migration journey. So the show of hands, how many of you here have heard of Fanduel? Okay, quite a bit of people. That's pretty impressive considering we're not yet live in California, but potentially a proxy for the growing popularity of sports betting in the US. For those who haven't heard of us, we are proudly the industry leader in online sports betting arena. Year to date, we actually have seen the same amount of bet transactions as we saw last year, and we still have 3 months left to go in the year. This growth has been staggering, and as you guys can see why we've been focusing on finding a scalable solutions to our data platform. So we are known for our sportsbook, but we're actually a collection of many brands, including our casino and horse racing apps. And with more data being processed each day, we realize that the tech stack that got us this #1 position won't be the same one that keeps us there. So we ingest a lot of different data points to give our customers a world-class experience. For example, our bet transactions table processes over 250 million records per day. This data can power things like our marketing decisions, our betting lines, and even our responsible gaming program, which helps protect our customers. This isn't just another talk about why you should choose DBT. This is a talk about how we implemented DBT at a mature organization, both from a technical and collaborative point of view, and how ultimately we've changed the way in which our company views data as its #1 asset.
So as Phil has already alluded to, we were already quite a mature data organization. We already had set up a number of pipelines orchestrated through Airflow, which were executing SQL scripts that then loaded the data into the data warehouse. We work with a lot of data at Fanduel. It equates to about 6 terabytes of data per day. About 500 terabytes data stored in our data warehouse towards our data consumers, which equates to about 3.3 trillion rows of data. I've got an interesting stat about that. So someone on YouTube has scrolled through an Excel spreadsheet. So if we were to put those 3.3 trillion rows of data onto an Excel spreadsheet and decided to scroll through every single row, it would take about 3,500 years. So we would have to start in the Bronze Age to get to now to be able to see every single record and transaction in our data warehouse. As a sort of a bit of a concept, so you might hear us mention what's called our daily flash reports. This is essentially our pinnacle of data at Fanduel. It's our it's our daily report that we send to our data customers, and we try and aim, or should aim for it, to arrive before the working day on the East Coast. It includes things like total number of dollars bet, total number of customers, any number of new customers, and also the most popular bets. It is a health check of our data warehouse. So for our analysts, it's not just about how they consume the report. It tells them that the data from the day before has arrived, and it means they can run their workflows and analyze the data using the daily flash report as a marker that everything is correct. But of course, having a scaled, working with a large amount of data does come with its challenges. Firstly, our pipelines were very complex. We have a huge amount of dependencies that interact with each other. We also have a huge amount of SQL scripts that were executing during these pipelines. So for example, some of them were at least over 1,000 lines long of code, which made debugging incredibly difficult because you had to run each and every part of it to try and find where the error came about. And also for the new engineers that were working and developing on the platform, it took a long time for them to understand exactly what was happening and where they should be introducing their code changes. If there were any issues at all, everything was delayed. So we had a lot of issues if we had anything from files being delayed to failures in the pipelines. The moment we came across problems, everything downstream was impacted. Also, because we were scaling at a significant rate, it meant that we were trying to deliver data to our customers as fast as possible. So we kind of had an attitude that we'll throw data into the data warehouse and let our customers use that data how and when they want. Majority of the time, that worked relatively okay. But then when we did have issues, it was only really when the data customers were flagging sort of significant problems such as duplicates, missing data, or incorrect data. I'm just going to show a brief example of what our sort of dependencies would look like. So this here is essentially, each one is a little table that we use, and each is a job that we had running in Airflow. So as you can see, if anything happened to the left of this dependency tree, then we would be messed up for the reports at the end.
Thanks, Harry. So as Harry just described the problems that we were facing, I'd like to now go over the game plan in which we wanted to migrate all of our DAGs onto dbt. So first, I'd like to start off with some statistics. And there was a study conducted by MIT in partnership with Databricks, and they found that very large companies using cloud data infrastructure all faced very similar problems at their data orgs. We'll refer to these as modern data issues, and I'm sure many of you guys can relate to these. The first is roughly data duplication and data access issues makes it really difficult to answer complex business questions. Processing large amounts of data exposes inefficient SQL queries. And more data means more edge cases. And as a result, data quality tends to go down. And being a company that loves making bets, we bet that migrating all 15 of our data products onto dbt would help us improve on a lot of these modern data issues I just described. So the scope of this project can be summarized in three main measurable objectives. The first being to increase data quality, increase development turnaround time, and finally to reduce SLA failures. And we arrived at these goals because we found that A, they were measurable, and B, they would provide immediate impact to our analyst stakeholders. So here at Fanduel, we have a running theme that there are two seasons, the NFL season and the NFL offseason, and it's safe to say that a lot of our project timelines are centered around these time windows. The journey we're sharing today dates back to the beginning, to last year's Super Bowl and goes all the way up until this year's NFL kickoff. So we were given the 2022 NFL offseason to complete a pilot project for the dbt migration and then use these learnings to scale to the rest of our data org. So this was the playbook that every DAG at Fanduel went through. It was roughly a three-stage process. So the first was we migrated the entire DAG onto our internal Airflow DAG factory. The idea here was that the more that we can templatize and standardize our code, the more reliable and maintainable this code base can be, and ultimately this makes it more scalable. The next is for all of our source data, we went from an ETL paradigm to an ELT paradigm, and the idea there was that by refactoring the data ingestion portion of these data pipelines such that we are loading all of our source data in our data warehouse to be as close to the way in which we received that data as possible. And lastly, once these two steps were completed, we then took the data transformation portions of these pipelines and made them into dbt models, and we reworked the logic so that it was dry and modular. So with just one NFL offseason to deliver this pilot project, we set out on 4 major objectives to deliver over the course of 4 months. So the first one is to set up a small team with dbt experience, focus exactly on one product. We chose Sportsbook Online. Establish best practices and development procedures, and finally use all of these learnings and come up with a rollout plan for the wider data engineering org.
So in order to achieve the goals that Phil just laid out, there was only one problem. We didn't know how to write DBT. So we ended up partnering with Brooklyn Data Co. To form the pilot squad, Bookies. By migrating our premier product, Sportsbook Online, we would set standards and best practices across the entire organization. By combining our knowledge of Fanduel's business and infrastructure with Brooklyn Data's DBT experience, and we built DBT models, implemented data quality testing, and solidified our working model. So on the left-hand side is an example of our legacy logic. Sorry if it's hard to read, but that's also what we were working with. So these long single transaction queries were really difficult to troubleshoot and were highly resource intensive on Redshift. So our mission was to break down this logic into sources, intermediate, and MART models. That query's still going, by the way. All while maintaining data integrity and minimizing impact on our data consumers. So by the end of the pilot, our skill sets had merged and we were prepared to socialize DBT knowledge to the rest of the data engineers.
Thanks, Mike. Yes, so now we had devised our game plan. It was time to roll that out to the wider data engineering org. So the way we did this is that we came up with 4 steps. Firstly, we had to train our engineers. A lot of our engineers had not had DBT experience, so we had to get them familiar with how to write Ginger templating, how to deploy models, and how to just develop on DBT. Once they were comfortable with that, it was then time to migrate the models following the steps that Mike had just alluded to. This was quite a simple process. We just break down the models into those 3 stages, and then once we're ready to start validating. What we wanted to do was make sure that we were minimizing the effect that we had on our data consumers. So for them, it's just about accessing the same tables, same data, but we're just changing what we're doing in the back end. Once we were happy with the validation, we could then release the model out into production. Because we already had quite a complex data pipelines, we needed to make sure that we were migrating the models at the right time. So we didn't want to migrate one table that did not have its dependencies already sorted. So we were able to track this using a mirror board just like this, where each of the little blobs is a model that was being migrated in production. So we could track which models had been completed, which were still yet to be done, who is also migrating those models, and how far off we are from moving towards the end of our data lineage. For us, though, validation was probably the key thing here. Because we didn't want to disrupt our data customers, we wanted to make sure that the data that we were getting out of these models was matching what we currently had in production. We were able to sort of leverage different validation approaches, but majority, we came to the conclusion of using the DBT Audit Helper. What this would do is, for those of you that are not familiar with the Audit Helper, is it gives us a rundown, field by field, what percentage matched in validation and what percentage matched between the production. Obviously, this is very useful because it will tell us which fields are different, so we can go and investigate how they are different. But this was not the perfect solution. With our large tables, particularly like our financial transaction tables, running a full validation was incredibly costly. So we had to come up with some limitations into how much we actually run, so we're not running a full validation on 14 billion records, for example. The other issue is that this only gives you sort of field by field the values matching. What it doesn't do is it doesn't give you the data types. So in some cases, we could have issues where we would have an integer model or an integer field or a decimal field that gets casted to a string somewhere in our pipelines. For us, this was not being picked up. It was only then, once we merged into production, that you could get these issues picked up because customers or other models couldn't then perform transformations on those fields. And then finally, it was a good learning experience for us because it meant that we actually dived deeper into our logic. And it did highlight, in some cases, where we had some flaws in our current logic. This then raised more questions about how we would approach these discrepancies. So firstly, sort of the key questions that we would ask is, why is there a discrepancy? So one of the things that we wanted to do was dig deeper into the data to make sure that we understood where this discrepancy was coming from. Was it because we'd just migrated some poor logic or we'd messed up somewhere? Was it because we had better access to historical data, so numbers were coming up differently? If we did find an issue, we had to ask ourselves, who do we notify? Do we need to let product know? Do we need to let our data consumers know? So that we could then take action and either fix the issue or keep it going. In some cases, because the logic, we were happy that this is how it was been, we did not need to change the logic, or it might not have been a flaw in the logic all along. If we were deciding to make a change, we had to make sure that we let our downstream consumers know that we were making a change. So we had to let them know what tables were affected or what was being affected, what fields were affected, and how it was affected. And then the other question was, if we were making a change, how far back do we need to fix this? Is this something that we need to backfill fully from all historical data? Or is this something that we can just introduce at time of inception of the new DBT model?
So now I'll be going into some of the technical challenges that we encountered during this migration. So as more engineers onboarded onto DBT, we started to encounter resource contention between data engineering pipelines and analyst pipelines, and it was also difficult to scale our Redshift clusters with our growing compute needs. So in order to tackle these problems, we investigated root causes and devised different solutions. So one challenge that we've encountered was, at this point, we had five separate teams migrating models across 15 products, and our continuous deployment was getting absolutely slammed. So we found that running full refreshes on every deployment was taking the lion's share of compute resources. So we came up with a twofold plan, which involved creating custom incremental macros and also disabling full refresh on deployment. By creating these custom macros, we were able to gain more control over our workload behavior and also build in functionality for our growing number of streaming sources. By combining these solutions, we were ultimately able to control when models would be backfilled, and our customers were happier. Like, they weren't getting surprised by changes in history. The next challenge, our data engineering and analyst teams grow with our business, and we had more people working within the platform than ever before. So knowing that Redshift would be a limitation, we decided to run different proof of concepts on other data platforms, especially Databricks. So our POCs would cover runtime, engineering complexity of moving DBT models to Databricks, and also cost. So we chose Databricks for a number of reasons, one of them being that our machine learning teams already leverage both Databricks and the Unity catalog. Unity catalog governance also gives us a lot of new features, including dynamically masked views, which will help us with our personally identifiable information, or PII. And we were also interested in their intelligent workload management, which would optimize our query queues and over time reduce cost. So what we found after these POCs, setting up DBT on Databricks was fairly streamlined, and there was a 20 to 30% increase in performance against similarly sized Databricks SQL warehouses. So that leads us into our next slide, the post-game, where we have the same team but a different stadium, Databricks. After our successful POCs, the company has decided to commit to a migration onto Databricks. Our plan would also pass through a few different phases. In the first phase, we would be handling setup, where we create Delta Lake infrastructure and also refactor our governance policies around Unity Catalog and its new offerings. The next phase, we would develop new data ingestion pipelines to load staging data into the Delta Lake. And then, this is the stage that we're at. We're currently in the process of porting our Redshift DBT models over to Databricks. This includes several steps like converting Redshift-specific functions to Spark SQL, This is an example of some documentation that we made to help developers when converting their functions. And then also build dbt around our new architectural designs and the new offerings that Unity Catalog would give us. Then we want to, while the data engineering pipelines are migrating over to Databricks, we also want to maintain our data integrity so that we can support our data consumers that are still on Redshift. A lot of our analyst teams, they work with cross-product pipelines. So even though one product might get moved to the Delta Lake, they might still be dependent on other ones that are still in flight. And then finally, we have one unified data platform where all of our data teams can live.
Mike, and now for the highlight reel. So to revisit some of the goals that we set out on earlier, the first, to increase data quality, we measured this by seeing a 13% decrease in data support tickets. For the next two bullets, you see a massive increase in these two numbers. And a big reason for this was that, frankly, before we had dbt, we've never really had a good way of implementing both cataloging, documenting our columns, and also data quality tests. And as you guys know, with dbt, it makes it fairly straightforward to do this and implement this in the YAML files that accompany every one of those dbt models. For the next goal that we had, which was to improve development turnaround time, we measured this by seeing a 28% increase in the resolution time for our data support tickets. And then also a big win was that just generally, I think developer experience went up because when code is more modular and dry, it's just much more easier to read and maintain, and therefore it's more scalable. And finally, to reduce our SLA failures, and I think this is the most interesting one, is that the most impressive of them all, which is that we've met 100% of our SLAs over the last 4 months. So yeah, that's right. We haven't missed a single SLA in the last 4 months. So now to compare some stats between last year's Super Bowl and this year's Super Bowl, you can see that we actually got an increase in about 40% in our betting volume. Except now this time around for this Super Bowl, we saw a reduction in the runtime of these pipelines in about half. And in the weeks leading up to the two Super Bowls, for the one last year, we were meeting roughly 48% of our SLAs, and this year and this time around, we met 100% of them. So some key takeaways. First, create a playbook. If not already, follow Scrum best practices as much as you possibly can. We also have a saying at the company, Jira or it never happened. Document your data, diagram your data pipelines on tools like Miro or Lucidchart or any data visualization tool. This is great for not only the engineers understanding the complexity of the dependencies, but also for TPMs and engineering managers to plan accordingly. Next, don't be afraid to hold training camps, finding team captains and making them subject matter experts. We found this to be really effective in socializing dbt knowledge. Next, dbt is fairly straightforward to learn, but we believe much harder to get good at. So the following best practices is the learning curve. Next, if possible, loan teammates to different pods. We have many different data engineering pods at the company, and we found that rotating expertise across the different pods and making the overall team more knowledgeable helped with delivering our data products. Finally, don't be afraid to call audibles. You should never be married to your legacy architecture, and of course, always build for the future, not the present. And finally, we'd like to end on a quote: "Success is a team sport." So the three of us recognize that it takes a village, or in this case, many villages, to deliver on this product. And not many of us, not everyone has had a chance to share the stage with us. So we want to take a time to thank Brooklyn Data Company. They were very helpful. The data architecture team, all the data engineers, both here and over Zoom. The data product team. I'm not missing anybody, right? Just everybody, the program management team, everybody played a big part.
Thank you all for listening. If you've got any questions, then please feel free to reach out. On those screens are our slides, our links to our LinkedIn. We'll also be around as well, so if you want to ask any questions in person, then please feel free to come up. And finally, I wish you all a very pleasant and happy, exciting Coalesce, and look forward to perhaps seeing you all around later over a beer or two. So, thank you.